Hello there, and welcome to this course on data wrangling with Python. My name is Valentine Mwangi, and I'll be your instructor for this course. I have been a curriculum engineer for the past 4 or 5 years, and this has entailed designing and delivering learning experiences such as these. And I'm quite excited to undertake this responsibility for the next 2 to 3 hours. Hopefully by that particular point, once we are finished with this course, you will have gained a skill that's important, that's going to help you go about your day-to-day tasks, or even just help you to transition into using advanced tools for data analysis or for data science. And that is using Python for whatever data related tasks that you might have. So let's get started. So the agenda for this workshop is as follows. So we are going to start off with getting to understand the objectives of this particular course. Then after that, we'll get to go through an overview section where we will talk about what is data wrangling, why do we perform it, and also who primarily would be concerned when it comes to doing this particular kind of work. We will at this point also get to understand the concepts that we're going to be going through. I will be delivering these concepts in the first 10 minutes in some sort of theoretical way. So this is the idea is just to help you to understand what exactly these concepts entail theoretically and also in an in-depth manner before going to practice extensively later onwards. After those 10 minutes of what, why, and who, we will get into the reading and quiz section. And at this particular point, we will provide you with a reading, which is what you see on your screen, which will give you some in-depth aspects about the different concepts that we're going to be going through. The idea is that by the time you're getting into the practice work, you will have understood why and what those concepts, each and every concepts that we're going to learn with regards to data wrangling entails. For example, reading data, exploring data, handling missing data, handling outliers, etc. You'll have understood in an in-depth way what those concepts entail and be in a position to be able to perform those particular concepts whenever required. So that will take up us about 10 to 15 minutes. So you'll go through that reading, and once you have gone through that reading, the idea is that you're going to go through a quiz afterwards. So within those 15 minutes, you will also ensure that you have finished this quiz. It's just a short multiple choice quiz that will provide along with all the resources that you need for this course. If you're watching, by the way, this video on YouTube, you might have you might not have access to this. And this is usually for community members of Afterwork. That's afterwork.ai. But if you are really interested in following through, you could go to the practice session of this particular video course. We have provided a sample resource that you can be able to use to follow along. But generally, once you have gone through this particular quiz, then you should be in a good position to have understood the basic theoretical aspects of the courses that the concepts that we're going to be covering. Then after that, we'll go into a practice session, and that practice session will entail going through a practice notebook that we have curated, and it will cover all the different data wrangling concepts that you will need. So from reading data to exploring to performing standardization techniques in an effort to ensure that data is uniformly looks uniform for further analysis, to handling syntax errors, irrelevant data, etc. We have curated this reading that contains examples of how you apply those concepts, as well as how you also and as well as also, aside from just the examples, we've also provided challenges that you can use to be able to go about those particular concepts. Like, for example, for duplicates, you can see there's an example that allows you to put into practice this particular concept, and also there are challenges which will come after that you can be able to work on. In addition to this practice notebook, there's a solution notebook again to those particular practice challenges that you will get, and you can use them as we continue throughout the course in order to just verify whether your solutions were okay. Once you're done with the practice work, we also have a project that you can work on that will help you to put into practice the skills that you have learned at the beginning in the practice work, as well as in the theory and reading work. And the idea is that you are able to put into practice those skills in a real life project. And you're going to be answering some few questions. We will give you some starter code that will just, it will be just some document that will contain just some minimal code that will just allow you to be able to go through the content itself. But at the same time, we'll also give you the solution notebook for that particular project. That is, of course, if you're an afterwork member, you'll have all the resources that we will have provided in this course. If you're coming in from another platform, maybe Udemy, you also should have that, or Skillshare, you should just have those content already with you on the platform. Again, if you would want to get maybe certified, you could always submit your project on our afterwork platform, and we will have a look at that project and give you some feedback. And if it's a good, it's a well done project, then we will actually give you a certificate, which we will also be able to access on the platform. So yeah, so that's just a bit of what to expect generally. This is the structure for the next 2 to 3 hours. They're going to be intense. You're going to be doing a lot of work, and hopefully at the end of it all, you will be in a position to say that you can apply those skills within your line of work, or not necessarily within your line of work, but maybe you might also decide, I don't know, to use them somewhere else. But the idea is that you'll have acquired the learning outcomes that we will have set out to have achieved at the very beginning. So let's get started. So by the end of today's session, you expected to have achieved these learning outcomes. So you should be able to recall the methods of loading data sets from CSV as well as Excel files. You should also be able to apply data exploration as well as just data exploration techniques to observe records, to explore them, to understand data generally. You should also be able to evaluate data sets, possibly for inconsistent column names, because that will help in performing later operations that you might end up getting in the course of your learning experience. Aside from that, you also are expected to be able to have acquired the skill of analyzing data for missing values, outliers, as well as duplicates, be able to create filters to get records with specific values and conditions, and lastly, be able to generate exports of data sets in CSV and Excel formats. By the way, you do not necessarily require to install anything in your computer for this particular course. The idea is that you will be in a position to use some of the online platforms that we're going to be using in this particular workshop. So you won't be required to install any sort of software. Starting us off, what is data wrangling? So data wrangling generally is the process of transforming data from its raw format. Sometimes when data is collected, usually it may not be in the format that would be suitable for analysis. And the process of transforming that raw data into a format that can be used for analysis is what we would refer to as data wrangling. The diagram that you see on the far right is a diagram that showcases stages that are for working on a typical data science project or machine learning project, where we start by defining the question at hand, the research question. Then we import data, we look for data and then understand it. Then after that, we would prepare data and later onwards perform some analysis, whether it's modeling, which just entails creating machine learning models, then later evaluating whether your solution actually met the set business criteria or metric of success that you had initially set at the very beginning. So generally, data wrangling would normally happen during the data understanding as well as the data preparation phases. So there are quite a number of techniques that you will learn. And there's a popular saying that goes, that usually talks of that much of your work as a person or professional who works with data will be spent on just doing data cleaning or data wrangling aspects. It's usually you're going to be spending 80% of your work trying to figure out how to ensure that your data is in the right format for further analysis. And that is typically what would really happen in this case. So that was just to give you a good idea of where data wrangling techniques would come in handy. And we would normally use such techniques to be able to process data for further analysis. It could be for just maybe creating dashboards, creating reports, creating or training machine learning models, or some other specific use case that would come into consideration later onwards. So that's just what data wrangling entails. In some contexts, data wrangling can be referred to as data pre-processing or data munging. Some other aspects, so those are just different words that sometimes could be used alternatively to data wrangling. So if you see a course somewhere that's written data processing or data pre-processing with Python, this is actually what we're going to be covering. It's still the same thing as data wrangling. So the techniques that we're going to be going through in this particular session will entail the following. So there's going to be some techniques on reading data, on exploring data, missing data, understanding how to work with missing data, as well as understanding where missing data arises from, or what are the origins of missing data, understanding how to find as well as manage outliers, how to find duplicates, how to deal with them, how to also filter for data, how to sort for data, perform splitting, merging, and concatenation of data, as well as export data that you're going to be that you have already cleaned, possibly for further analysis. So why would we want to perform data wrangling techniques? In order to save time when it comes to that's one of the reasons, to save time when it comes to even further analysis. You might, especially for data engineers, because data engineers, their primary responsibility is to prepare data to be used by other stakeholders. So they usually create what are called data pipelines, and the output of that is usually transformed data that can be used by other data scientists or data analysts for whatever projects that they are working on. So generally, data engineers would possibly pull data from different sources, and they would combine that data and try as much as they can to put it in a format that is usable by other data professionals. And that process actually helps save time. So they apply data wrangling techniques to this data that they later maybe store in a relational database, and other professionals would pull that data from that relational database. Now, that saves time because for other professionals, they don't have to now pull data and perform those other data transformational techniques. Again, I think that touches on also making data usable. Sometimes data that is collected may not be in a format that you can simply create a summary chart or summary table from. So you need to ensure that you have cleaned data to put it in a format that can be used for further analysis. To aggregate data originating from the multiple sources, again, if you have data coming from CSV files, from Excel files, from relational databases, you will need to figure out a way of, you will need to apply these techniques, whether it's combining data, which we've talked about, splitting, merging, and concatenation, in an effort to pull this data together and be able to work with it. Again, for data quality and reliability in some organizations, it's important that the data that you are collecting is also in a format that is acceptable for other stakeholders, or it even does communicate something about that organization in terms of how it collects data. So data quality and reliability is also one of those reasons why one might end up also applying such a what you might end up applying data wrangling techniques generally. So who would apply data wrangling? I think I've touched on a bit of this. Data analysts and data scientists, normally when they are working to prepare possibly data, they might want to prepare maybe reports, they might want to create dashboards, they might want to create machine learning models. Then they would first of all need to ensure that the data that they're working with is in the right format before actualizing those deliverables. For machine learning engineers, these are professionals that primarily work with just creating machine learning models and maintaining them. Again, they would need to ensure that the data is prepared for training, and that data, in that preparation stage for preparing that data, would need to have entailed the application of those data wrangling techniques. Finally, data wrangling, I had already given an example of data engineers who would, in the process of creating data pipelines, apply those data wrangling techniques in order to ensure that the data that comes out of their data pipelines is reusable data, is usable data by other stakeholders. So, all right, so at this particular point in time, we are going to go through the reading and quiz. This is the actual reading that I had provided you a bit, I showed you earlier, which is this reading. We have already shared this on our platform, so you can be able to download and go through this reading. It might take about 10 to 15 minutes. Once you have gone through that, just go through this quiz. It's a self-graded quiz. It should give you an idea to what extent you have understood the concepts that we have outlined in this document. So once you have gone through that, you should now be ready to now undertake the next step, which is now the practice work. So you can pause the video and then we will continue later. All right, so having gone through the reading and the quiz, now we're going to go through the actual practical aspects of those concepts that we have talked about. That's in relation to reading data, exploration, standardization, syntax errors, irrelevant data, how to handle irrelevant data, how to handle duplicates, missing data, filtering, let's perform filtering, sorting, splitting and merging, merging and concatenation, outliers, exporting data. So we'll go through all these different aspects. I'll be taking you through the examples, but I'll leave you to work on those challenges by yourself. But you could always check the solution notebook that we've provided to be able to just see how you can be able to go about if you had actually gone about those challenges in the acceptable way. So getting started, what you have here just for introductory purposes is a notebook. A notebook is just a document that data scientists or data analysts or machine learning engineers would use to put their work. This is just not only code, but also could be text data. It could also be just links to interactive medium, possibly videos or even images. So generally a notebook, you could compare it to more like a Google Word document, but the idea is that when you're working with a notebook, you have the ability to execute code within the notebook. So what we are working with, a notebook also has what are called cells. There's a code cell and a text cell. So at the very top, you can see there's a text and there's a code buttons. If you click on either of these, you're going to be creating any of this. So a code cell would contain code that we can be able to execute and be able to perform some sort of operation, as well as, and on the other side, a text cell will just contain text, which will just help explain whatever that you're doing. So what we have here is a notebook that contains all that content that we have created, examples and challenges, and we are going to, it's hosted on Google Drive, and through an application called Google Colab or Google Collaboratory. And it's free for users at the very basic level, but you could always decide to download the actual original project, or so notebooks. There's the original project, which would allow you to have notebooks run on your computer, which is called Jupyter Notebooks. But in order to work with them, Jupyter Notebooks, you would need to install a program called Anaconda. So that's a separate training for it's way different from this, so I won't be covering that in this course. So the first thing that we need to do is to click on connect to connect our notebook to not even connect, don't even go there. That's the first thing that we need to do, is to make a copy, save a copy in Drive. So we need to go to File, then Save a Copy in Drive. This will save a copy of this notebook, and you can be able to edit that copy. You can be able to save that copy in Drive. If you don't go through this step, so if you don't go save a copy in Drive and work on the new copy that you will have, then you won't be able to save changes. So if you close your browser, the changes will just disappear. So it's important to just save a copy in Drive and have that particular notebook for your own education matters. So let's do that. Once you have done that, I will open mine in playground mode so that I don't make any changes. It's a master copy, so I don't want to make any changes. So starting off, the first thing, so I've done that. The next thing that I would do is to click on connect to connect this notebook to Google servers, so that I can be able to run my code from there. Now, while when we're working with a program like Python, a programming language like Python, there is what is called just a chunk. Python comes at the very core with the ability to just write code, but writing code from scratch may be a tedious task. So what happens is that when it comes to performing specific tasks with a language, let's say for example the Python programming language, there's what is called a library that we can be able to use in order to perform specific tasks. So programming languages usually come with libraries, which are generally chunks of code that have been written by other experts, and that chunk of code will allow us to perform a specific task. So for instance, there are libraries, which is just a chunk of code that has been written and well tested in production for creating visualizations, like static visualizations. There's a library called matplotlib. There's a library called Seaborn for creating interactive charts. There's a library called sklearn or scikit-learn for performing machine learning tasks. There's a library for data manipulation, which we're going to be using, called pandas. So pandas is one of those libraries that we can use, that we can use for performing data manipulation tasks, and this is what we're going to be using. Aside from that, we're also going to be using another library called it's called NumPy. NumPy is also another library. It will provide us with code that allows us to perform conversions, but generally we would say that it's a scientific computing. Well, not really scientific computing, there's SciPy, but this would provide us with just functions or code that we can be able to use to apply mathematical operations to the data sets that we are going to be working with. So generally those are just two libraries that we're going to be working with. So just wanted to just give you a quick idea. So we are not going to really be writing code from scratch. Normally that's how you would work with. So you try and understand first of all how to work with just different tools for different tasks that you want. So first of all, we are going to import pandas. So this is what you see is the code cells. We have two code cells. In this code cell, we have this, what is highlighted here in green and has just a pound character in front, is actually it's actually comments. This is a comment. This is a comment. You'll find we have put whole lots of comments before our code cell. So you can always just follow through. If you're lost in the video, just read and try and understand what's happening. But the first thing that we're going to be doing is to run this cell. Or just run it anyway, but ensure that you have already saved a copy. You shouldn't get that pop-up message. But once you have run this, which you'll see a check sign, it means that we have imported pandas, which is a library for data manipulation, as PD. So in any place that you'll see PD, it means that we are going to be using pandas. The same case, import numpy, just run this, import numpy, which is for, we can use to use for scientific computations. So run that. So once we have done that, we have imported our prerequisites. Something to note, by the way, if at some point in time you pause this video and you go do something else and you come back and you realize that you have to run the cells, all the cells that you're working with, maybe you are in relevant data and you went somewhere and what is called a session expired, like, you know, you came here and your notebook disconnected from the servers, or your internet somehow started playing around with you and it stopped working at some point in time. Sometimes it happens. You would just have to come to the very top and start running these code cells again. Like for instance, import pandas as PD, the same case. The same case with other cells in other sections, the previous sections, because some of the work that we're going to be covering here will be a prerequisite for the next sections. All right, the first concept that we are going to be covering is reading data. Sometimes data can be stored in CSV files or Excel files. So for now, we're going to be learning how to work with Excel, CSV. All right, so to get started, the task that we have here is to load a data set that's a CSV file that has a particular URL. So to load a data set from a URL, so this is the URL that we're going to be loading the dataset from. So we can use pandas' read CSV functions, which is here. So we say df, which is a container, it's a variable that we're going to be using to store our dataset. So df equal to pd, remember pd from here, pandas. So we use the read CSV function from pandas, and then inside the function, inside the parentheses for that function, we specify the URL and we put quotes for that. And now the outcome of this, the output of this will be stored in df, and then we will use the head method function to be able to print out the first 5 records. So this df.head will actually print out the first 5 records. Something else is that when we store data that we have read from some sort of data source inside a variable using pandas, we normally refer now to the variable name as a data frame. So a data frame is just a 2-dimensional data structure that we can use to represent a table of data with rows and columns. So in our situation, in any case where we want to work with this data set, which is stored in df, we will be referring to the df data frame. So run that. You should be able to see the first 5 records of this data set, df data set, which you can see. This is an index column. It's not necessarily useful for now, but you can see we have this column name, sepal length, sepal width, petal length, petal width, and species. So these are just pieces of just the first 5 records of our data set. So once we have done that, we can also decide to even just look for 10, we can specify how many records that we want. We can even say 8, and we will be able to get 8 records instead. So normally, normally it depends, but not by default, just 5 gives you a good idea of the first 5 records, even just the structure of that table that you're working with. All right, the next thing, if we wanted to load a CSV, so for instance, we had a CSV dataset located in our computer, so we might want to upload it to this notebook on our Google Colab. We can do it this way. So sometimes our dataset may not be in a URL or something, could be maybe in your computer. So you would, of course, initially go to File, then New Notebook, then you create a new code cell by clicking here, or you can just go at the center and click on that, and you'd have a new code cell. Let me delete that, and then you can write this code that you're going to use to import our data. So to be able to assuming that we have this cities data set in our computer, so I'm just going to download this data set. I'll just drag my mouse on top of the link, then click on follow link, and that should download that data set to my computer. You may not be able to see, but I'll just load that. I'll show you how you can be able to load it. So I'll click on this particular icon on the far left, and then I will click on this icon at the very top. So if you find yourself clicking here and ending up somewhere else, that might be tricky to come back. You could always refresh the entire page and then reload run the cells again. But we don't want to upload our data inside anywhere. Just click on this particular icon over here, and it should give you a pop-up message that you can use to select the downloads, the cities dataset that has been downloaded. So just trying to locate my cities, which I hope you're able to do that. Let me see. If you just select the cities dataset that you downloaded, and sometimes browsers can decide not to download the dataset. So one of the things that you could do, you could just highlight the dataset, the URL, Control C, you Control copy, you copy, then you go at the very top, then you paste it, then enter, and that should download that data set, and you will see at the very top it's done. And then you can go back to your notebook and upload that data set, and then you just click on OK, and it should be uploaded, which you can see here. Just note that we don't want to take this data set inside sample data. That's another directory, which we will bring a bit of some complexities when you're first learning. So first, just bring it to this particular point. If this also becomes a problem when it comes to uploading, you can just drag your file here, and that should also work. So once you have it there, you can now in your code still use the same approach as we did here, pd.read.csv. Instead of the URL that we had here, we would just name the cities, the name of our file, cities.csv. If you downloaded maybe multiple files, you would also need to ensure that if this is, this is one, maybe the name of the dataset that you uploaded is one, you also need to take into account, you also need to ensure that the dataset itself name is as exact as what you have here. If there are spaces in between, ensure that you have also taken that into account. So in our situation over here, we will load our dataset, cities CSV dataset, into df cities data frame, and then a variable of a data frame, and then we preview the first 5 records. Please note that the variable names are different. Data frame names is also different. Like df cities is different from df over here. df has an iris dataset, and now df cities has cities dataset. So run that, and you can see we are good to go. So next thing that we're going to continue to, so we now have an idea of how this data set looks like. Okay, now work on the challenges, and then we'll come back to continue from where we left off. So work on the challenges, then have a look at the solution notebook, then we'll go to the next thing. All right, so data exploration. The next thing that we're going to be going through is now data exploration. Initially, you did see that we loaded 2 data sets. We loaded the DF data sets and DF cities data set. So one of the things that we are going to be doing is now exploring this data set, understanding it a bit more. Yes, we used the head function to be able to identify or to pull the first 5 records and just have a good scan of the data set, but now we might want to understand other aspects about the data set, such as possibly how many records are in that table, how many columns, etc. So to be able to determine the number of records in the data set, as well as also determine the number of columns, the number of columns, we can use what is called the shape property. So we specify first of all the data frame name, df, that's the iris data set that we initially had. Then dot shape. So if I run this, I should be able to get 150, 5. 150 actually represents the number of records, then 5 represents the number of columns. Normally, if you drag your mouse on top of also, you know, the data frame, the code itself, you would get some help from let me see if I can be able to see. Yeah, it even just gives us a data frame with shape. It also gives you the same information. Work on this challenge and then let's continue this challenge over here. All right, if we wanted to get the last 5 records from a data set, we can do the same, but now using what is called a tail function, so df.tail. So if I run this, I should be able to see the last 5 records, the 150 records. Remember the first index, the first record had index 0, so the last one is 149. So this is, it just gives us an idea of the last ones. Work on challenge 2C, and then we can continue and challenge 2D as well. And you'll note that you will use a sample function for this challenge 2D to be able to get the desired records. Checking the data types of a data frame. So initially, so when we are working with data, we normally have what are called data types, and these would allow us to be able to so we would assign data types to different pieces of information for us to later onwards apply mathematical operations. So for instance, if we wanted to convert possibly a certain column such as temperature from Fahrenheit to Celsius, degrees Celsius, then before we perform that operation, we need to ensure that we are working with numerical data, that we are not working with textual data. So it's important that you apply the right data type. But before we even apply the right data type, we need to explore to understand what data types are there within our column. So dtypes, df.dtypes allows us to be able to do that. So dtypes is also another property like dot shape, but now this is different. This one gives us just a summary of the data types that we have, and also it does also yes, it gives us that now just an idea of what data types that we have. So it tells us that in the df data frame, sepal length has a float, has float values. The same case with sepal length, with petal length and petal width. But now the species column has object data type. In Python, object is usually representative of textual data. So when you have some textual data in a column, normally that will be represented using the object data type. So in our situation over here, we actually have a correct data type. So this particular in this situation, our data types are good to go, so we can be able to apply any sort of mathematical operation that we want. Maybe create a new column that is representative of maybe some of these particular columns. All right, work on those challenges and then let's continue. Moving on, standardization. So sometimes we might want to ensure that the data set that we are working with, it has some sort of consistency in a certain aspect. Maybe column names that are lowercase, which will help us be able to reference them later when we are performing. Possibly we're looking for certain values within a column, or trying to understand whether they are missing values in a table, etc. So in order to rename columns, so we would first of all in our case, we want to now work on the renaming columns aspect. We are going to load this data set from this particular URL. It's a CSV data set, and explore the first 5 records. But this is a data cleaning data set, which we can see it doesn't really look in the right shape. So we would need to ensure that we have all records in one column, or not all records, but each column in its own, each column value in its own column. We need to also transform the column names. Some of the pieces of data are in capital. We can also see that height is in a different format. Maybe you might want maybe a metric system height sort of. So we could also do something like that. So let's transform this data set. For uniformity purposes, we might want to first of all ensure that all the values we see here that are separated by semicolons have belong to one particular, it belong to individual columns. So let's first of all do that, and by doing that we can see that we have what are called separators, which is a semicolon. So to be able to tell pandas that we have a separator that we can use to separate each and every value, we can do that when we are reading our data set. So we would say read CSV, then the column, so in this function we have so a function normally, so this is a function, and inside the parentheses we normally have what are called parameters. So the first or arguments, but for our use case over here, we're just going to call them arguments. So the first argument in our situation over here, we have a URL that we have defined. Then the second argument would be the semicolon, which is the separator that we want to tell pandas to be able to use in order to structure this data set appropriately. So if we run this, we should get a properly set column name. So as you can see, we have a table name that looks good. We have some output here, but this just gives us an idea of what's happening behind the scenes in terms of development for that particular the particular arguments that we are using, but don't mind so much about it. The information that we have is actually sufficient enough for us to continue. All right, so once we have that, maybe the next step would be to clean the column names, so renaming these column names. So we might want to remove any sort of white spaces in between and replace it with an underscore. We might also want to ensure that all the column names are in lowercase. We might also want to remove probably there could be spaces before, which are usually called leading spaces. If there's some space before the column names or some trailing space after the column names, you might also want to sort that. And in some other instances, maybe there are also some other special characters that are inside the column names that we might want to replace, possibly. Like for instance, here we're going to be replacing some space that is between the column names with underscores. Maybe you could have a hash character that you want to replace, or even some parenthesis character, left parenthesis character that you would want to replace. Then we can be able to do that as you'll get to see. So the first thing that we're going to do, actually we have to be able to perform those operations that we've mentioned, like be able to remove leading and trailing spaces before and after. We can use what is called a strip function to be able to lowercase all these column names. You're going to use the lower function, or that means converting all characters to lowercase. Or we can also replace just maybe the space over here with just whatever character that we want. It could be now an underscore. So to be able to do that, first of all, we are going to pull the column names. To be able to reference actually the column names, you can say df.columns. This will just give us the columns that we have from the df dataset df. But now, by the way, now df, which was initially we had the iris dataset, so we replaced now the value of that iris dataset with now this new dataset df. So df has these columns which are actually here, and when you look at them closely, they look okayish, but you can be able to clean them. So to clean them, you just say df. So we have retrieved these ones, these are the column names. So to replace now these columns, we can be able to say df.columns. You want to apply this particular function, strip this, will strip all leading and trailing characters, convert all characters to lowercase, replace text, which is replace the spaces with an underscore, and replace left characters, which we don't actually have, but just gives you an idea of what you could do with nothing. There's no space here. And also replace the right hand you can replace the right parentheses character with now also nothing in that situation. Just move a bit, yeah, so you can be able to see that. So in our situation, we are actually applying all these functions. This is the first function that we are applying: str.strip, str.lower, str.replace, again str.replace, as well as str.replace, and we are chaining them. So we are applying them together on this particular column, all the columns, and then the outcome of this particular operation, we are replacing it, we are storing it here. So the final df will have column names that are clean and in lowercase format. As you can see, this is what we have. You can just ignore this warning. It just talks about future replacements of pandas, but we'll do another course once they have done that. All right. So the next thing that we can be able to do, this is the first option. The first option, just we're able to use methods, functions, to be able to perform this operation. But again, we can decide to apply, we can decide to replace all these column names manually. So instead of applying these functions, we can do that manually, as you can see here. So this is a list that we created that has the new column names, and then we replace them in df.columns. This is not the most efficient way, so we'll just for understanding of how you can be able to do it. But because you might make a mistake somewhere, and you could always you always need to ensure that you don't do that. So this first method is the most recommended way, where you're using multiple functions to apply to all the different column names that you're working with. Now, with those who are just column names, now if you wanted to apply some of those operations, some of those functions, let's say perform some, you want to lowercase at particular the values within a column, then we can use str.lower. So we first of all define the column that we are working with, say df, then city column, which is this column, and we want to apply the str lower function to that column, so that all these ones are in lowercase. Then we would apply it as shown. Then we replace the outcome of this. We replace df city values, the original ones, with now these new values, and we can preview that, and we should see that the city column has lowercase characters. All right, moving on to the next thing. We can also perform some sort of conversion or apply some mathematical operations. We had already determined the data types and seen that height. Well, we haven't determined the data types. We could actually determine the data types for this column. The one that we did was for iris data set. So we can say df.dtypes to determine the data types for the columns, to ensure that we are working with just data that's okay. So name and city are object, which is string data. Country, the same case, it's just text data or string data. So height is in integer format. Okay. We would expect height to be maybe to have a floating point value, because someone could be 1 meters, or could be 97 centimeters, no, not 97 centimeters, but it could be 120 centimeters, 150, etc., or etc. But here we're working with, I think this is it's in inches. Yes, this is in inches. So maybe one could have float here. So the same case, float, this is okay, but account B is in integer. This needs its currency. So this is just currency data, so it needs to be in float format to account for decimal places. And the same case with total count, but we'll do that. Something you'll note here is that we have this missing value, which will bring a problem, but we'll also learn how to work with missing values later. So to perform some conversion, so we can apply this operation. So we can take the values of d height, the height column, the f height. By the way, this is one way that you can be able to reference a column, or you could also be able to reference it as shown. This is also another way. It will still work as the first one. Just go back. So you apply 2.54 because 1 inch is equals to 2.54 centimeters. That's what we want for the data set here. So we want to convert the height from inches into centimeters. So and then we apply that, and the outcome of that will be this. This is what we have, which is a bit more realistic. All right. This is we can also see. So again, if you remember, maybe you've done another course that we have done in the past, like one on introduction to Python programming. We had mentioned that when you perform some operation, let's say a float times an integer, the outcome is usually a float. So in our case over here, we should expect the f height, which here height was integer, so we should expect it to be a float now. So df types, we should see that we now have a float for height. To apply some data type to a particular column, so assuming that we want to put this back into integer format, so there's a data type that we can use, int64, which is this int64. We want to apply that to that particular column. This is how we can be able to apply. So we can say the f height, this is what we're going to be replacing. Then the f height, we're going to apply this particular data type. Now we're using np.int64. np just means we are applying a property provided by NumPy. So that is something that we can also explore. So NumPy actually provides us with the ability to be able to convert with different data types. So we are using pandas and NumPy in our situation over here. So the expectation is that we're going to have height back again to int64. Data types, we can be able to cover this in another workshop. It's an extensive course that data engineers primarily, it concerns really data engineers, because in most cases when building infrastructure, which is what data engineers would do, data infrastructure, they would need to ensure that they're using the most minimum resources possible for that collection, as well as for data to be moving around within an organization's resources. So the idea is that you can be able to use the most efficient data types. Like for example, in our situation over here, height could even be accommodated by int16, which takes much more lesser memory space. All right, work on the challenges, then let's continue. Moving on, syntax errors. Sometimes you might have some syntax errors in your data. So by the way, while you're working on challenges, ensure that you have used the right data frame names. Otherwise, you will have to, if you replace maybe df data types, you might have to, again, when you're going through the examples, have to go through again that process of just running these cells with df. So just keep that in mind. So when working with data sets, you might come across some syntax errors, which are just spelling mistakes or typos. The origin could be human-made, or it could be system, influenced. So, but to replace those syntax or mistakes, we can use conventionally. The easiest way is to use what is called the replace function, which we are going to learn. But you can use what are called spelling checking libraries. There are quite a number of them, but you tend to learn about that when you're working with textual data. This workshop on data wrangling focuses primarily on just the numerical aspects, but when it comes to textual data, you can be able to handle such kinds of mistakes using specific libraries, not really pandas, but other libraries. That is a separate workshop on text pre-processing or text wrangling with Python. We'll do that workshop some other time. So let's do this df country. So we replace, so again, that replace function that we had. We replace Germany, so which is this particular has double Y. Again, this is taking into consideration that you have checked all the unique values for maybe that particular column that you're working with and gotten that Germany has been misspelled correctly and like this. So you would replace Germany with Germany as shown, and then you would and that. So before I do that, I just want you to see Germany. You can see this Freya Bismarck has that. So let's run that. So you can see Freya Bismarck with this. All right, so the next thing that we can be able to do is strip leading or trailing spaces. That means just remove the spaces before and spaces after. So if I run this df city, we are going to, this is actually going to help us just see the column and values for the city value. So we're just going to see that, and you can see actually you would expect all these values to be on the very left. Over here on our pandas data frame, you can't notice those leading or trailing spaces, but here you can be able to notice them. But you can also be able to apply some other advanced operations that will allow you to even determine how many of these columns values have leading spaces as well as trailing spaces, but we haven't covered that. But let's just first of all work with this. But this just gives you a good idea. You may not be able to print out all, but just for surety, you can just apply this method. And how you strip both leading and trailing spaces is you use the strip function. You can also do that for just the left or the leading trailing spaces by just the leading spaces. You can remove the leading spaces by using the lstrip method, or is it rstrip method? Yeah. So, but for both, just use strip the function, this function. And you can see now they are a bit more clear. Actually, not on the left-hand side I had mentioned here, it's on the right-hand side, as you see. Work on the challenges, and then you continue. Irrelevant data. Sometimes when you're working on a research question, you might realize you may not necessarily require some data that you had initially imported. So in order to possibly get rid of that data, which might be like extra columns that you have, you can do that as shown. So for instance, we wanted to drop the cities column. So from that particular data set that we were working with, from this data set, we wanted to drop this column. So how we are able to do that is use the drop function. So we can be able to do the same here. So we say drop, then we define the first argument as the column name that we want, but we can also put multiple of them. So we can also make it, if we wanted another column, we can just specify it there, column 2, etc. Just remain with 1 for now. Then we define axis as 1. So we're saying that we want to remove a column. So by setting axis to equal to 1, we'll actually be able to remove column. Then in place is actually, you need to ensure that you use in place to equals to true in order to ensure that this particular change, df, this dropping of this city will be applied to the df data frame. If you don't use this, if you don't set the in place, sometimes we call it argument or parameter, argument to true, let's just call it a parameter this other time. If you don't set it the in place parameter to true, the problem is that you won't have this particular city column applied to the df data frame. So you could always ensure that you always do that. If you don't have this, say assuming you run this code and it works, it may not work, it may not necessarily work on the initial data set. So if I run this, you might realize that the city column is still there. The reason is because we haven't applied that change. So for that, you might want to maybe do a df like that. This is the other option of just replacing the outcome of this to this particular column, and you should be able to see it. But let me just call it df1 so that I don't want to make changes to df, so that you're able to see that it's going to work. So you can see there is no city column. I've created another data frame, but I'm going back to df in a while. So you can see it has worked, but what we want to do is to apply to use the in place method. So this will actually apply changes to our original data frame. So if I run this, I should be able to see that the cities column is gone. All right, you can be able to drop multiple columns, as you can see here. So height and weight, we can also drop them. Again, do that. Assuming that sometimes you might want to fix maybe some errors. So for instance, you might want to ensure when you look at this data set, you have account A, account B, and we want to ensure that account A plus account B is equals to account C. So, I mean, that's a logical thing. It makes sense that way, because if you look at something like this record, this doesn't make sense. So you want to ensure that the total makes sense. So that way to fix it is maybe get the columns values for this account A plus account B, and that will ensure that we have stored in total account 2. But we may not want to replace this initially to this particular column. We might want maybe to cross-check first of all before continuing to replace that, and ask questions. It might be really good for maybe fraud cases where you're trying to understand why is this column different from this other one. So in such a situation, that might be important. So you might want to create another column, so account to account 2, and then possibly look for check for whether this particular total account A, this column, is equal to this column. If it's not equal, then you raise a flag and you get those records and you follow up through. Again, that's something as a data scientist you might want to do also. So we have created total account 2, which is total of that, and we can see that we have some questions to ask about this record. And then we can use, we can create another column that will have true or false values. So for instance, for this column, we will have another column that will have a false value. But in our situation, the same case here, we also have false value. Here we'll have a true, this is true, this is true. Then we can be able to use a filter to retrieve those false records with false values. So in our situation here, what we are going to be doing is using NumPy to create another column to be able to specify that. So use np.where we say that in this particular df where this particular expression is not is equal to true, then we have a value for that new column total account, which with a question mark is true. If it's not true, we're going to give it a false. So if we run this, we will be able to see that we have this new column. So we have true, true, false, false. So we can raise questions about these two columns. Not a number usually is missing value, but ideally you should have 0 for that use case, for that case. All right, so then we can retrieve those records. This is a bit more complex. I've introduced some complex cases here, but don't worry about it. So we say total account, this column over here, we can say that if it's equal to false, that's what we want. We want to retrieve, for cases where it's equals to false, we retrieve now those records. So if I run this, we should be able to false. So we have those 3 records in our data set, and then we can raise questions about these particular records. This is again useful for maybe work that you might do as maybe a data scientist to identify fraud and everything else that that concerns such. And we've given some questions. You could correct the values, you could delete the values, or even decide to leave them as they are for certain reasons. But again, you could also decide if you had many records, you could also get the number of those records by simply see this expression. You just enclose it with a length len function, and you'll get the number of records with the false values. All right, work on the challenge, and then we continue. Okay, duplicates. Duplicates, just data that has been repeated in a data set for whatever reason. Sometimes you could have such kind of data. So in our case over here, we're going to work with a different data set. This is an NBA data set. It might take a few seconds to load. So we have this data set. We have loaded it from this URL. It's a CSV data set. It has 458 records and 9 columns. We're using this. You might have come across this data set somewhere else. It's only for learning purposes. We have just ensured that it's easy for learning purposes. All right, so let's do this. We can identify which observations are duplicates using now the duplicated function as shown. So we say NBA df, which is the data frame that we are working with. Then in the quotes, we say we specify that we want to identify those records. We want to retrieve those duplicate records by doing the following, by saying nbf df.duplicated, and we store now those records inside nba df. We are not previewing them, but we can be able to find the number of those duplicates, as you can see here, which we don't really have any, so it's 0. Example 2, if we wanted to drop those records, assuming we had those records, we can be able to do that by saying nba.drop duplicates. So run that. And yeah, so that's just generally how you would. And if you wanted to, so actually we dropped them, but at the same time we might even want to maybe, I don't know, yeah, you could even, like in our use case over here, this is dropping them, but we might also want to store them somewhere if we wanted to use them later somewhere. I'm not sure where, but you could do that as well. Okay, so in our use case, this is the other use case that we might come across. So assuming that we also wanted to identify duplicates by only one column, so by the country column, we can use still the duplicated method that we had here, but now we just specify inside the parentheses the column that we want to use for assessing the duplicate records. So we can see that there are certain columns by using the Sweden, not by the country, sorry, by the country column. So those are the 2 columns. All right. Again, you can drop those 2 particular. This one was just for identifying, but we can then drop them as shown. So then that's it. So we can drop them, and yeah. So actually here I had mentioned something about doing something with them. This is not what you would be able to, you just drop, and then you store the new data set here, data frame here, without now the duplicates. But if you again wanted to identify those duplicates and do something with them, you can use this method over here, but you don't use the you don't specify the column name. So in our situation over here, we have 6 unique records, so and 7 column names. All right, work on the challenges, and then we can continue to missing data. Okay, when working with missing data, there are different ways that we can be able to check for missing data, possibly in a entire data frame. So this is one of the ways when we use isNull. isNull is one of those methods, but this method will just tell us whether each and every value in that data frame is missing or not. For instance, if you look at that data frame, we have true, this is missing, but the false one means that the false values means that they're not missing. There is some value there. Again, this may not be the most convenient method, because I mean, you cannot be able to make sense of this particular data set if it's quite large. You might have to perform some other operations on top of that. And that is what we actually do. So isNull gives us here some useful information, but then we can check for missing values in each column, still using isNull function. So we apply another any method, any function on top of the outcome of df.isNull, and it will tell us whether each column, there are missing values in each column. But again, this may not necessarily be 100% useful. The most useful bit would be if it tells you how many values, and you can be able to do that by using the sum function, which just tells us in account A, there's one missing value, the same case with total account 2. If we also want to check to see if we have any missing values in the entire data frame, this is the other method that we can use. So just we want to just know whether there is any missing value, yes or no. So that's another method that we can use. Just having the values, values.any values, and also just say any. I'll use the any function. Again, these may not be the best ones. Maybe this could be a better method for that. To drop the missing values that you have, maybe missing records. If you have records in your data set, in your data frame, and you wanted to drop those missing values, so you can use a drop an a method, function, sorry. Drop an a function, you apply it to the data frame and store now the output of that, df no missing. So you can be able to now check for missing data using the method that we had here. So you'll see that we'll have zeros. But again, you need to assess and understand whether dropping the missing value, the records with missing values, would have any sort of impact in your analysis. So in our situation, we don't have any missing values. With the drop an a method function, we can be able to also specify how we want to drop the records. Sometimes you might want to drop the records if only the records, all of them, have missing values. So if they have only just one missing value, just keep them. But if they don't have any missing, if they don't have any record in that row, then you can always drop it. And this is how you're able to do that. So originally, this was our data set 87. And we could still be able to use other methods to determine, like this method, to determine how many records will be left. If we want also to drop the columns, you can also drop the columns, not just the records, but the column if they contain missing values. But now we use again the drop an a function, but we specify the axis parameter. We say axis is equals to 1 to specify now we want to work with the columns. But again, here we also specify that we also want to ensure that to drop a column if it has all the records missing, which usually is rare, but sometimes it could happen. And that is important, so you can do that. Lastly, we can also set some sort of threshold, assuming that we have records with less than 5 observations. So if you have a record that only has, say for instance, 5 missing values, you might want to specify that if this record has 5 missing values, then drop it. So the thresh parameter allows you to be able to do that, but in our data set we don't have that. Let's try to. But remember, you'd also need to apply to use, I forgot an in place. Here you could do that. Let's just use this, the in place parameter, but you could do df is equals to, we just do df1 so that we don't replace the old one. Threshold 2. 1, let's try that. 6. So if All right, so let's continue. So generally what happens here is if you have, say for instance, a threshold, so you're setting some criteria saying that if this particular record does not have records greater than 6 in our situation, then drop that particular record, or you could just do the same case with 5, etc. So this is just a way of also ensuring that you're able to narrow down to whatever use case that you have. So, but usually the decision to use to perform a particular operation would be as a result of your expertise as a domain expert. The other methods that you could use, what we're doing here, we are handling missing values by dropping them, but you could also use for instance, replacement operations. You could decide to replace missing values with a mean or median. That's another course that we will do on handling missing values or handling missing data. Or you could decide to use some machine learning techniques to perform that particular aspect of imputation. So that is something that you can be able to do, but the easiest way is just using just dropping them. All right, work on the challenges and then let's continue. All right, the next thing that we're going to go through is filtering. So sometimes you might want to only work with a subset of data that makes sense with regards to a research question. So maybe if we had a data set that had categories, maybe, or even continents, Africa, had Europe, had Asia, and you only want to work maybe with a data set that only pertains to African countries, then you can be able to filter by that particular continent column, which would be records with the value Africa for the continent column. So filtering, we can be able to select different records with that regard. So let's first of all load this data set. We will load this data set again, iris data set. It's the one that we had initially loaded. And then we can now select records where maybe in that column there are certain values, like is exactly the same value. So for instance, if the records in this particular column name, petal length, if the records, well, we're actually selecting all records in the iris dataset that has petal length as 5.0, and we use the is_in function for that, as you can see here. And we can also specify other values that we also want, and we would also get records that also have those other values. In our case, we don't have that, but let's say we did petal length 1.4. We should be able to get that. Petal length is in 1.4. Okay, let's do something else. No, we shouldn't do that. We should do so in our situation over here, I think the assumption here is that this is an object or has textual data. So in our situation over here, we shouldn't get anything. That's the reason why. But assuming we had irisitosa, assuming let's say this was species, and this is irisitosa, we should be able to get records with that. Okay, this is capital. So yeah, so this is what we should get. But if we wanted to work with this, we can be able to use a different method. So we would remove all this together, and equal to that is equals to if iris dot not species dot petal length is equal to 1.4, then I think this should work. So we should get records with 1.4. Yeah. So the first method was assuming this was just the data frame here column was header data type that was an object. So but species is the one that has an object, and it worked for that method. All right, work on challenge 4, then continue. So selecting the records where the column doesn't have certain values. So in our case over here, we might, so in our situation, so here we had, okay, let's work with this. Let's just work with this. So here, we'll just slowly, you just modify this, equals to 5.0. So iris petal length 5.0. We normally use this character to negate this operation. So for all the records with petal length is 5.0, these are the ones. But if we want the ones that don't, the other ones, the ones that don't have this value, we usually use this character, which is usually just next to the 1 on your keyboard. So you run that, you should be able to. Okay. Okay, so let's see whether we can be able to do something different. I'm just trying to look at let me see whether we can be able to figure this out. So here, okay, I see where the problem could be. So the problem is here. So this only works with, initially we had this will work with, again, object type. So this will actually work because all these records, there are actually 150 of them, don't have this particular, they don't have this string, this value 5.0 for petal length. But if I run this, there won't be any records. So in order to, because we are working with floating point values for petal length, what we can do is to say iris.petal length is equal to, we can say not equal to, then we say 5.0. Yeah, so that should work. So, okay, well, let's say equal to 5.0 so that you're able to see the effect of that. Petal length 5.0. These are the records, there are 4 of them, but not equal. We usually use this sign, not equal, to exclamation sign. All right, work on that challenge and then let's continue. If we want to select records with maybe greater, which are greater than a particular number, so you can say iris df petal length greater than 1.9. Again, you can also use the dot method to be able to do the same thing. It's still going to work. This or this method will still work. So we want to retrieve records with greater petal width of greater than 1.9, petal length width of greater than 1.9, which you can see. All right. This other method we can use, the query method. This is actually the same for the number. This is a different method. So the other method that we used earlier was this method. We used this method. Also did use this. Yes, we use that method, but we can use a query method to also have some expression. So we can have this expression, petal width is equals to 1.9. This just actually applies our change on the iris df. So we don't want that. It will actually replace our original results and we won't be able to get any output here. So I just remove that and run that. So query, this is a shorter way. Petal width, where petal width is equals to 1.9. Petal width, where is it? Is it 1.9? No, it's not. Okay. Petal width. Petal width 1.9. Why is it giving us that? I see the issue. So the issue is we need an in place. So if if um if we are going to replace this, but when we replace this, we won't be able to, okay, let's just do it the way it is. Let's run this. We should actually replace all our the original data frame, but we can also use the second method where we say iris df2 is equals to iris df. So if we run this, we will get 1.9. But now in this data frame, we can be able to say where we have sepal length is 2.7 and petal length in 5.1. So we'll have two records, this and this. All right, we can also get the same result as this other one without using the query method, but the other method that we had initially. We define the first one and we use the AND operator. Then we also use, this is the ampersand operator. Then we also we have the second one. So we have two expressions, but you can also have a third one, fourth one, etc. And then we run this to give us those two values. Right, work on 5D. Then we continue. Sorting. When it comes to data, sometimes you might want to sort our data in ascending or descending. Sometimes research questions might ask what are the top three or bottom three. Then, using ascending, the concept itself helps in answering such a question. So, to be able to do that, we can be able to still, while working with our data frame, we can be able to get the data frame that we have. Maybe we filtered our data frame. Then what we can do is use the sort values function, and then we say, use the parameter. We set the parameter by, the by parameter to the column that we want to sort with. Then we set the ascending parameter to 1 in order to say that we want to to sort in ascending order, or descending if we want. We can use for descending, we don't change the parameter ascending, we just change this value over here. So ascending, instead we would just put a 0, not a 1. So yeah, we by sepal length, so you can see here. But I think you can apply it to a bigger data frame, that because this has already been modified, we modified it over here. Okay, work on challenges, and then let's continue. Sometimes you might want to merge two different data frames. Maybe you have a data frame that we pulled one data set from a particular data source, maybe a CSV file, and another one from a CSV file. Then we can merge them, as you're going to be seeing. So assuming that, first of all, we're going to use the iris data frame that we have. And then we want to, so we have this data frame, and what we want to do is to, in our use case, but now right now what we want to do is to split our data frame. So we want to split the species into iris and also virginica. So we want another column. So we want to have two separate columns, species and also subspecies column. Is it family? Yes, we want to have family and also subspecies. Family will be iris, and subspecies will be say virginica in that case. So what we want to do is split that data. Right now we're not actually merging, we're splitting first, then we're going to go to another example for merging. But for splitting, we can first of all ensure that we don't have any missing values. So we do this, we run this, and then we use a split function to be able to apply that split operation. First of all, we define what we want to split that column by, which is just a character in the column. Then we want to use, we set n is equals to the, n is actually the first appearance of this particular character. The first one, we can set it as second one, but we want to set it as 1. Then we want to expand. We just define expand as true, as to be able to just mention that we want to split this particular function and expand it generally, but by expanding just separate columns. So we apply this particular function to the species column, which will return a new iris df. It's a new column name. Then this new column name, let me just even copy this so that you're able to see what's happening. New iris df. You don't have to delete your code. Just follow through first. So new iris data frame will have iris. So we have iris. This new data frame will have iris, and we'll also have Virginica. That is what we have in that particular new column name. So the next thing that we want to do is to get the first name, column name, and we want to assign that to a column called family in our original data frame. So this is a new data frame with new iris df, and we want to set that new data frame, that column name for that old column, that family column name value for values as the ones that we have in this data frame. We have 2 records here, by the way, because we have 2 records over here. So once we do that, we also do the same thing for the second. So this is the first value, the first column, in the second column. So all right, so what happens here, just for clarifications, is that what we have done is that we have this new data frame. So this is the data frame that we are working with, that we actually got our values that we split and stored them in here, a new iris df. So in that new data frame, we have one column and another column. So the values of the first column in that new data frame, we store in a new column name in the old data frame. And that will be in the family column, and the same case with subspecies. And we drop the old column name species. Then we display our data frame. Oops, I've already deleted this. So I've already run this cell. But in your case, you wouldn't have. So you get this as the outcome. All right, example 2, assuming we wanted to concatenate 2 columns, so wanted to bring 2 columns together and merge 2 columns. Maybe you had first name and last name, you want to merge them into a name column. So this is how you can be able to do that. So family, so for instance, we want to merge family and species together. This is how you can be able to do that. So you would use the cat function. First of all, we would define that we want to create a new column called species. We are reverting what we did in the first example. So we create a new column species, and then we take the family column, the first family column, and then we concatenate it with, we apply this particular concatenation function with now, and inside that function, we define the column that we want to concatenate with, which is this particular column, and then we use a separator to separate the values of those 2 columns. And then once we have done that, we would again have the output of that stored in this new column species. Then we drop the old column names, the old columns. So the family and subspecies column, we drop them. Then we now preview our data frame, which will now have just species column. You can see here. All right, work on the challenge and then let's continue. Lastly, for this section, we can be able to concatenate. So we can, assuming we have 2 data frames and we wanted to combine those data frames. So this is just an easy example, but we'll have an example in the challenges that you can work on. So this is how you're able to do that. So this is data frame 1. This is we're just defining a data frame, just a simple data frame for ease of understanding with 2 columns, A and B, and these are the values, 2 records. Then we define another data frame. But now those 2 data frames have A column is the common column. So we can be able to define how, so if you want to merge both of these columns together, the data frames together, we can use the merge function. Then we say df1.merge, that's the first data frame. We want to merge it with df2 column, but now we want to merge it on the left. So we're going to merge it using using the A column. So we will use the A column to be able to merge that particular column, and the output of that will actually be, as you can see, we have ABC columns. We had AB and column C, which was in this other column. So we have that merged to our original data frame. Again, you can be able to do this, but the only issue is there are different ways that you can be able to merge columns. There's the right method, how in terms of you can specify, right? There are different ways, but we're just covering the basic ones in this particular course, but we'll, of course, over time, provide more content on those other ones. Right, second last section, outliers. So we have this data set, assuming that we wanted to find outliers. So let's load this data set. Country data set has that data, and we can check the shape of that data set. Has 1,704 records and 4 columns. So if we wanted to determine the outliers, we can use the IQR method, which is usually called the interquartile range method, where we can determine even just the distribution of that data set. Say the records that are normal are records that are between the 25th percentile and the 75th percentile of the entire records. So records that are outside that particular bound, so the first 25 and the last 75, those ones we could define them as records which we can consider as outliers. So IQR is the a method that we can use for finding outliers. So the range covered by the middle 50% of the data would be now data that's normal, but values outside that range, we'll consider it as outliers. So to be able to do that, we can use the IQR method by using the quantile function. So the IQR interquartile range, we can be able to subtract, to be able to determine those records, we can be able to determine the interquartile range, which would be Q3, which is the which will be the third quartile minus the first quartile. So we can be able to do that, as you can see here, using the quartile functions. Then once we have been able to determine the IQR range, then we can be able, for that data set that we are working with, we can then, using now the numerical data that we have, not the textual data, just the numerical data. For texture, you could use other different types of advanced text processing techniques, but for now it's just numerical data. We can then retrieve those records that have those values outside that interquartile range as shown. So we define the data set that we are working with. This is just the original data set, and then inside what we are doing is just retrieving records which are either, this is the first expression. This approach is more similar to the one that we used earlier onwards. I'm just going to drag my mouse to what was the section? It was the one that we had. Yes, it's more like this approach that we are using here, but only that we have two different expressions. So if I go to examples, so you'll see here we have this particular expression. So we have where Q1, so where this is the data frame with Q1 minus 1.5 times IQR, which is if this is less than this, or the records which are less than that IQR, we are going to retrieve them. The same case, we're also going to retrieve records which are greater than the Q3 values that we have computed. And we are going to be able to display those outliers as you can see. Actually, there are 317 outliers. Don't worry so much about this. This is just a way of just telling us that one of the methods here, quanta, will be depreciated, but there are already versions that we can be able to, there are alternatives that we can be able to use for that. But we can see our outliers are these are that you can see here, 317 records. And we can also explore them by just outputting them. These are the outliers. And sometimes you might want to leave them as they are, maybe because they're genuine, in this case. Maybe replace them with some other values, or even just drop them if you want. To drop them, we can just use the negation character, this character that we had also used for just selecting records that we don't need. And we'll end up having a clean data set with 1300 as from 1387 records opposed to the records that we initially had. All right, lastly, exporting data. Assuming that we have cleaned our data set and we wanted to export data to a CSV file and maybe put it somewhere that we can use for analysis. If you're working on Colab, Google Colab, which is this platform, to be able to export that data, we normally work with this module. It's another library that we can use, Python library. It's just a files library, so files module that we can use. So we just run this to be able to import it. And then, assuming that we had that data frame, so assuming we had this data, this is another data frame that we are creating, but let's just preview it. Assuming this is the data frame that we had, called it df, we can export it as shown. So we say df .toCSV. We use the toCSV function, and we define the new name of our CSV dataset, and then we download it. And if we run this, it should download over here, so you can see at the very top. Alternatively, you could also you can also access it here and also click here to download it. All right, so that's it. That's it. Okay, we have one example. Sorry. So we have the example which you can do. So you can use the 2Excel. You could, if you want to export it to an Excel format, you can also do the same thing. It's going to download and also create a copy over here. Okay, we don't have a copy there. Yes, we have it there. All right, so I think that's it. That's it with regards to this particular course when it comes to the practice work. So the next thing that you will need to go through is now in terms of the next steps, just to highlight that. The next steps that you will require to go through is now the project, which we have already shared. In this particular project, the idea is that you're going to apply the concepts that we have covered so far in order to answer these questions that you see here. Once you have done that, it's still again in this particular document, you will find the link to this notebook, which will be a starter notebook that will give you an idea of what you are actually going to be working towards solving for. And then once you have done that, it's going to ask you to go through this whole process. Once you have done that, you can access the solution notebook, or alternatively you could you don't have a look at the solution notebook, you can have a look at it later. But once you've gone through the project, you've worked on it, you could submit it for review, and then we're going to just send you a certificate of completion of participation in this course, and then you should be good to go. I think the next step that normally we recommend participants to go through is usually now working on data cleaning, specifically courses, just to get a good grasp of the concepts that you've worked on, but you'll start feeling that things are actually working on well. Alternatively, you could just go to another course that's on data analysis work, where you're going to be answering questions, creating summary tables, now creating reports that will actually answer business questions. Or you could also decide now to go into data visualization, because you now would be in a position to have your data clean. You have your clean data that you can use for further analysis. All right, so that's it. I hope you were able to enjoy this particular course. If you did, you enjoy this course, ensure that you do give it a good rating for other people to have access to it. And hopefully we'll be able to keep in contact, and I'll be dropping some more courses over time. And all the best in your journey, and bye bye.